All right, guys, in this video, we're going to be looking at some enthalpy of formation questions. I've got a multiple choice and a short answer. So here's our multiple choice. We've got a reaction, and it's just asking, what is the standard enthalpy change of formation for the reaction above? They give us their enthalpy of formations right here and their values for each molecule. They have to give you this information either in a data table or some form or fashion to be able to answer these types of questions, so always expect there to be the information you need to answer it. And delta H of formation is simply just going to be the products minus the reactants, or the delta H of formations of the products minus the reactants, and it would be the summation of them. So if we know that the delta H of formation for our C6H6 is 83, I get that right here, and we got to add that or subtract that from our reactants, and the delta H formation for C2H2 is 230, but we may notice that we actually have 3 of those, so we have to take 3 times 230, and if you take that 83 and you subtract it from 3 times 230, the answer comes out to be negative 607 kilojoules as your answer. Looking across the board, A does fit that math, so we have A as our answer. And that's all it is. That's all you got to do. So you just got to plug in, chug these numbers, and from the data that they give you, understand that it's the summation of the products minus the reactants. This is a short answer. So when it's a short answer, you're going to have to definitely show your work to get full credit, to make sure you get it also just to the right answer. It is very good to show your work. So we have a reaction here. Use the information in the table below to calculate the delta H of reaction of the standard enthalpy change of the reaction is in kilojoules per mole for the reaction. So here we have our delta H of formations, and we want the delta H of reaction. Okay, that's going to be the same exact equation. It's the summation of our products minus the summation of our reactants. And I'm going to do that in these colors. So one of my products is AgNO3, so that's this one. So that's a product, and there are 3 of those. I also have NO as a product. There's just one of those. And I have liquid water, which is right here, and I've got 2 of those. I also have Ag, silver, as a reactant, and HNO3 as a reactant as well. HNO3 is right here, and I've got 4 of those. Now, Ag, or silver, is not shown in our standard heat of formation data table, okay? But it doesn't need to be, and if they did put it in, it would be 0. And that's because the standard enthalpy formation of anything in its elemental state, in this case it's silver, it's an element, and it's a solid, so it is just going to be 0. So they didn't need to include it. They didn't include it, so you don't need to worry about it. So now I plug those numbers in. So with my products, I have to add 3 times negative 101 for my AgNO3 plus 90 for my NO3 plus 2 times negative 286 for my water right here. And then I'm going to take that summation and subtract it from my reactants. I've got 4 times negative 207 that I get right here. And then I just have to subtract. So some summation of that minus the summation of this right here. And my answer comes out to be, got it written down right here, negative 43 kilojoules per mole in this reaction. Okay, and that would be the answer. So make sure you show your work in the short answer and your answer, and make it sure it's very visible and easy to be read by the grader for these types of questions.